introduction. Thank you. Hi everyone, it's weird being on the other side. So, I'm Wayne Sebbens. I'm a software architect at Reapit, which is a global prop tech company. We've got a Brisbane office just down the road in Milton. And yes, I wore the shirt today on purpose. However, today I want to talk to everyone about a side project of mine, which involves a dictionary from a few hundred years ago, custom vector embeddings, and Aspire. This came about because of an intersection of some of my hobbies and interests outside of software development and .NET. So I feel like it also serves as a good introduction of me to the rest of the group as well. I'm actually giving a condensed version of this talk at .NET Conf next week. So tonight you're getting the extended director's cut. I'm going to start off with a quick bit of history and language just to provide some context. So hope we have some history and language geeks here. And by the way, those aren't typos on the title slide. The reason it's spelled that way will become apparent shortly. You'll also see I've included some relevant entries from the dictionary I'm talking about as the slide headings, just for some extra flavour. But first, how all of this started. So I participate in something called Historical European Martial Arts, or HEMA. Unlike reenactment, we're using modern safety gear similar to sport fencing. However, unlike sport fencing, we're using a range of historical weapons, such as long swords, rapiers, arming swords, sabers. And we learn and train from translations of manuals, treatises, and manuscripts, usually from the medieval and Renaissance periods in Europe. Who here has seen the film The Princess Bride? A few, that's good. So think of the back and forth in the sword fight between Inigo Montoya and Wesley on the top of the cliff. You're using Bonetti's defense against me, huh? You must expect me to attack with Capoferro. Naturally. But I find that Tybalt cancels Capoferro, don't you? Unless the enemy has studied his Agrippa, which I have. Bonetti, Capoferro, Tybalt, and Agrippa were each fencing masters of the 16th and 17th centuries. They all actually taught rapier at their own schools or have published texts that have actually survived until today. There's no lineage of teaching that has been passed down from those times though. So instead, what we're training is techniques and plays that we've reconstructed from those original texts. And so that often requires translating not just from one language to another, like say from Italian or Spanish to English, but from older versions of those languages into the modern day versions. I've included a couple of examples of some of the texts here. On the right is a page from Fiore di Liberi's Fior di Battaglia, The Flower of Battle. And it was written and illustrated sometime before 1409 in Middle Italian. And you can see it's demonstrating an old classic move of kick them somewhere painful. Flower of Battle is notable not only for being one of the oldest surviving fencing manuals, but also covering a range of armaments, from unarmed grappling and daggers, swords, spears and polearms, and even fighting on horseback. The middle image there is from Italian fencing master Vincenzo Saviolo's His Practice in Two Books, which was written in 1595 in early modern English, on fencing with the rapier and dagger. And that's me in the corner. That's me in a sword fight, fencing in a competition. Sorry about that joke, but not really. A contemporary and likely acquaintance of Saviolo is this gentleman, John Florio, who is an English linguist, lexicographer, and translator. There's a lot to say about Florio, but I'll try to keep this brief. First of all, he's believed to have been a collaborator of Saviolo's on his fencing books. Florio certainly knew of Saviolo at least, having written about Saviolo and his fencing school. and there are many Italian fencing terms that appear in Florio's dictionaries. Florio is also believed to have been an acquaintance of Shakespeare, yes, William Shakespeare, due to many literary and linguistic influences from Florio's own works that appear in Shakespeare's. And just to complete that particular triangle, many of the duels in Romeo and Juliet and several fencing terms in Love's Labour's Lost and Hamlet are seemingly borrowed from Saviolo's book. But Florio's connections go higher still. In addition to being connected with many nobles and ambassadors, he was a groom of the Privy Chamber, that's the most influential civilian role in the English royal household, to Queen Anne during the reign of King James I and VI. That's the same King James who united the English and Scottish crowns, as well as who commissioned the King James Version of the Bible. And Florio's influence still continues today. Florio is credited with contributing over 1,100 words into the English language, which is the third most after Chaucer and Shakespeare. For example, judicious, management, and transcription were all introduced by Florio, as well as several, shall we say, more vulgar words, which I don't think I'll be allowed to repeat here. So the main dictionary I'm talking about, which is called Queen Anne's New World of Words and published in 1611, it's actually Florio's second Italian-English dictionary. His first contained 44,000 definitions. The previous largest was only 6,000. However, New World of Words contains around 75,000. There's scans of facsimile that have been hosted on a website by Greg Lindahl, and it's a popular resource for anyone who is translating Renaissance Italian into English, but finding words in it can be a bit cumbersome. So this here is part of the first page of entries in that dictionary. Today we refer to this stage of the English language as early modern English. It certainly resembles modern English, much more than Middle English does. However, you will see some things that seem odd to us. For example, we have this long S in the word sign. We have the V in ablative being replaced with a U. However, there's also some cases such as under and unto where they use a V instead of a U, just in print. This here is an early form of the ampersand, when it's used to denote the ET and ETC, as in etc. Fun fact, it's called ampersand because when we used to recite the English alphabet, we would end it with and per se and you can see how that becomes shortened to ampersand. The letter J doesn't really exist in print yet in English, so instead an I is used. At this point, we also used IE, where today we would use Y. And it gives you a hint as to why the plurals of these words is IES. Similarly, you have this trailing E on several words, which also hints why we use ED for the past tense of certain vowels. You'll also notice a U there being used in place of a W. So you might see how cumbersome trying to locate particular Italian words might be across the 600 odd pages in this dictionary if you were having to try and find things on images of each of these pages. You might also notice that for some of these entries, it's pointing to another word to find the actual definition of that word. And considering how much English has changed in the last few centuries, Italian has also had a similar evolution. There are online translators like Bing and Google, but they don't often understand some of these older archaic words or languages. And yes, we have things like Wiktionary, which are great, but even it's actually lacking some of these older words, and I've actually checked.
This is after Thorin, though, right?
Sorry?
This is after the Thorin, the E old.
Yeah, that's more Middle English.
Yeah.
All right, so what I wanted to do was to make searching this much easier. Unfortunately, even typical or modern OCR doesn't perform well with these, in part because of, well, those older letters and characters that we've seen, but also because of some artifacts from either the printing process, where the ink is smudged, or from the scanning process. There might be some specialized OCR models based on large language models, but when I started this, I wasn't aware of anything. So I actually started the slow process of transcribing. And I actually got about 2,400 definitions done. As if transcribing all of that, it doesn't take long enough, I would usually add transcription notes as I was going, just because of some of these old words or phrases. And of course, fall into rabbit holes. So one of those rabbit holes was for this second phrase, Neil read what, which you can kind of imagine in Hank Hill's voice. By the way, to Neil read what means to anneal red hot. So while I was trying to determine that I discovered Project Gutenberg's transcription. If you haven't heard of it before, Project Gutenberg is named after Johannes Gutenberg, who was one of the few credited with the mass-producible printing technology that started the European printing revolution. You may have heard of it if you've read Stephen Toobe's annual performance improvements in .NET blog posts, because he'll usually use Project Gutenberg to show improvements in regex or string searching. The Gutenberg transcription of Florio's dictionary is available not just in a HTML format, but also a plain text format using what appears to be some kind of markdown. It almost is. There's just a couple of quirks that I can't match to any markdown library. At this point in time as well, retrieval augmented generation and vector databases were on the rise. So all of that gave me an idea on how I could go about creating a modern version of the dictionary, which will be a website with a vector database storing the contents. To really make it work, however, I would need to parse the dictionary, extract the Italian words so they could be looked up, along with their definitions. But people in the 17th century didn't really have much consideration for making machine-readable content. There's a lot of idiosyncrasies in the dictionary's format to contend with as well. So, for example, idem is from Latin and Middle English, meaning the same. So in that case, it's just referring to the same definition above. So abacista here has the same definition as abicieri above it. That is a caster of accounts, as in an abacist or an expert at calculation. A definition might just point to another dictionary entry, such as an alternate spelling. It can appear either before or after the entry it's referencing, so that can make matching them a little bit difficult. So here, abaco is referring to the later definition of abaco, and meaning an abacus. Italian, like many other European languages, has a diverse range of a language feature called conjugates. In English, we usually have simple conjugates for past, present, and future tenses of verbs. For example, run, runs, running, ran. However, many other languages, like Italian, have a lot more conjugates for things like the singular and plural cases. Adding is and are to verbs kind of does the same thing in English. In Florio's dictionary, typically the conjugates share, well, typically when the conjugates share a common lexeme or root, that's a kind of prefix, only the first word would be spelled fully, and then the remaining lemmas, the versions of that conjugate, would be written with only the stems or the suffix. However, when they don't have that common root, they're all written individually. So in the fourth example there, we have abilieri, abilisco, and abilito. However, in the example after it, it's uduer, odo, udi, and udito. Finally, sometimes multiple different spellings would be listed in the same entry. Complete contrast to either using a dem or using as to reference another entry. So the last example here is adua, adu, and aduo. And yes, that is tennis as in the sport played at Wimbledon in the definition there. So how does one go about parsing a 600-page book? Line by line. So this here is the main loop of the parser. It's mainly state management and reading lines into a string builder as a buffer. Using the iasync enumerable allows the parser to start its thing as soon as it hits the first line, rather than having to wait for all 4.5 meg to be loaded into memory. There's about 175,000 lines in the text file, and only 166,000 actually cover where the dictionary entries are, and that starts 600 lines in. So using async enumerable means that you can just blitz through those first 600 lines. And fortunately, in the way it's formatted, the page headers would serve as a good indicator that I've actually reached the entries, and then there would be a clear blank line between each one, which indicates that I can go through and flush the buffer. There are a couple of edge cases, like what's shown on the right there, where there would be some words that are grouped together, and that would require some special handling. And then this is part of what parsing the definition itself looks like, especially to handle all those idiosyncrasies I was mentioning before. So like, there's that special case of the grouped words, the idem handling the previous entry, and the conjugates and different spellings. I won't go into depth on this because we'd be here all night, and there's more interesting parts to talk about. But this is all public on my GitHub repo, so if you're interested in how this works and handles the conjugates and that, definitely go and have a look, and feel free to reach out if you have questions. However, overall, I'm really pleased that the parser ended up being pretty generic in terms of being able to handle the fluidity of English and how messy some of the entries ended up being. There were only a few places that I needed to special case for particular patterns or errors in the transcription, and Project Gutenberg was really kind and corrected them when I pointed them out, so big thank you to them. There were fewer instances still where I needed to add the Italian words themselves into the code for the parser to handle. The largest part is handling those variations, like the conjugates and the spelling differences, but that owes to the complexity of how those were actually formatted. Who here actually uses test-driven development? Yeah. Yeah. Me neither. But I really want to call out that I found myself using it while I was writing the parser. I would be doing a continuous iteration of adding test data for some of the entries in the dictionary, updating the parser until the test's passed, and then running some utility console applications that are also in the repo, which would, there was one to just automatically analyze the parsed data, look for anything unexpected, and then also another that would export to an Excel spreadsheet that I could actually manually go through and look at. Any issues I found would be added back into the test data and repeat, just test-driven development. That's actually what led me to discover the different ways that conjugates would be listed in the dictionary, as well as some of the errors in the transcription itself. When I actually started this, I was originally wanting to make a translation model. But by the time I'd finished writing the parser, I'd decided on making this an online dictionary. But the question here is, how do I make this searchable? So one option is our classic database searches. Typically, that requires strict matches on the string, either like entirely or just a starts with. And I've seen enough in some other period texts to know that there can be a lot of spelling differences or even just plain transcription errors. So I needed something to be able to search in a fuzzier way. We could do searches based on minimizing Hamming or Levenstein distances, but those end up being quite complex, especially to do in a query in SQL. Whether you love or hate large language models, there's been some interesting technologies that have developed or gained popularity alongside of them. For example, as retrieval augmented generation for large language models was being talked about a lot more, vector databases would also often be in that same conversation. There already are some existing options for creating vector embeddings that you can store in a vector database. For example, there's string to vec, fast text, which are often used for machine translation models. And of course, there's OpenAI's embeddings model. However, all of those are designed for computing vector space representations of phrases or parts of sentences, which is a lot coarser and broader than I want. Also, string to vec seemed like it would, I'd end up with an extremely large vector space, right, in the tens of thousands of dimensions. As well, like Python. I'm a .NET developer. Just quickly, for anyone who's not familiar, I want to cover how vector databases especially are fantastic for the kinds of fuzzy searches that I'm doing here. So in other words, like when you're not after an exact match on a piece of data, but a close match. So one of the typical ways to measure that closeness is called cosine similarity. It works by calculating the cosine of an angle between vectors. So the more similar that two vectors are, the closer to one the cosine similarity is. If two vectors are unrelated, the cosine of the angle approaches 0. The examples here have just 2 dimensions because that's easy to diagram and show on a screen. 3 dimensions is a little bit harder to display, and then more dimensions gets hard to even conceptualize in your head. But math and computers don't have any of these problems, and they can go to hundreds or even thousands of dimensions. If we had a vector database seeded with some text and their vector representations, we can quickly find the most similar entries to some search term just by also converting that search term into a vector and then ordering by the cosine similarity. So for this example here, our search term is what is an amphibian? And the most similar result actually contains several of the words in that search term and in that same order. However, that's not the case for several of the other most similar results here. In fact, you'll notice that one of them is even in Italian. In this case, the strong results for those is in part due to how OpenAI's embedding model is structured, where it's placed related terms extremely close to each other within the vector space. And that's extremely beneficial for things like document searches. This here at the top is the formula for calculating the cosine similarity between two vectors. Basically what it's doing is it's calculating what's called the dot product of the vectors. So it's really just multiplying each vector's dimensions together and then dividing that by the product of their lengths. So what this results in is that the magnitude or lengths of the vectors don't actually matter. It's just the angle between them. At the bottom is how we would calculate this using C#. At the very bottom is just doing it in a loop. It's actually quite a lot simpler than the math equation makes it look. However, today we have the system numerics tensors library, which contains just a cosine similarity function that we can use. Of course, vector databases handle all of this for us, so we don't actually need to write this. However, what we do need is a way to create the vectors for both seeding the vector database and then for performing the searches. And for that, I used ML.NET. I think it's one of the more underrated and unappreciated libraries in .NET. While most of us would equate it with like training and running neural networks, there's actually a lot more to it than that. We have data transformations that would typically be used for preparing data for training a model and maybe some post-processing. But amongst those data transforms are a few ways for creating embeddings. To start, there are several pre-trained embedding models that are already accessible through ML.NET that we can use with apply word embedding. For example, here I'm showing the fast text Wikipedia pre-trained model, which has about 300 dimensions. Going a little bit further, one of the pages in the ML.NET docs explains how to prepare data for training various models. Right at the very end of that page, it covers preparing text for training a sentiment classification model. And that actually gives us the first hint on how we can create our own custom embeddings models. So we have the featureized text transform there, which will take string values and create a set of features from it. So for any given text value, we can get a numeric vector that will look similar to this. However, instead of transforming the data at that last line there, we can actually just stop after fitting the data. And now we have our very own custom embedding model. Featureized text itself is actually applying a few individual transforms, which shows how we can go even further with customization. This here is what featureized text actually breaks down into. And at the bottom is an example of what's occurring in each transformation step. So normalized text and tokenized into words, they actually appeared before with the pre-trained one. So normalizing is just converting the text into the same form. The default's just making it all lowercase, but we could choose uppercase if we wanted. We also have control over whether diacritics, that's the accents over letters, punctuation and numbers should be kept or removed when normalizing. The tokenize into words is splitting the string into a vector containing each of the individual words as a separate dimension. Remove default stop words is removing some predefined unimportant words. It's specific to a given language. The default's English, but you could use French, Italian, so on. Map value to key is mapping each of the words in the training data to a key or category. And that's key, excuse the pun, for the next step, which is producing engrams. So that's creating sequences of consecutive words or groups of letters that are encountered in the input text. And then that last one, normalize LP norm, is actually just a scaling function on the engram vectors. So it'll convert all the dimensions from holding either a 0 or 1 to having a value between 0 and 1. It does this in something called LP spaces. I'm not even going to pretend to understand what it's actually doing. There's many more transformations within ML.NET that might be applicable for any use case that you're using it for creating custom embeddings for. So far, I've only been showing some of the transformations for text, but there are many, many others, including some specifically for images. Hopefully you can also see at this point, like, depending on what you're using it for, some of these steps could possibly be skipped. So, like, for example, the removing stop words is removing some noise so that we can have smaller vectors. But that could be entirely unnecessary, or it could be removing some feature that you actually want to keep. For example, A is a word with definitions in the dictionary that I'm using. So that's not something I'd want to be lost in the model. Also, your input may not even actually be language, but it could be some other data that has semantics or structure to it. I could see this kind of approach being taken with, say, a hex string that represents some audio, or even the ATGC in DNA sequencing. So the first 3 transforms here wouldn't even be necessary. So I came up with a plan for creating my own vector embeddings for the Italian words. Because I want to make it tolerable of diacritics, the accents above characters, each of the Italian words would first need to be normalized. So convert everything to lowercase, remove the diacritic marks, and then remove everything that isn't a letter or a space. By the way, these square braces around the O is just a notation that's used by the transcribers to aid pronunciation. So once it's normalized, each word would be broken into engrams. It took a bit of experimenting, but I ended up using 1 and 2 length engrams called unigrams and bigrams. So while I could just use the unigrams, what would happen is if there were any anagrams like melon and lemon, they would score similarly in the similarity. So the bigrams helps enforce the orderings of pairs of letters. When I first did this, my first model used trigrams, as in engrams of length 3. And it worked really well with quadrant, but it resulted in the vector space having over 4,100 dimensions, which is more than Cosmos DB's indexing algorithm support. At the bottom there is, at the very bottom, are a few representations of Stelleo in 2 formats. So the first is the value in each of the 451 dimensions, well, attempting to be shown. It drags on and on. The second one is a way of representing those kinds of large vectors by just showing what is non-zero. So this is what I want my embedding model to produce. How's this actually going to look in the ML.NET pipeline? It's really just these 2 transforms. So rather than mapping words to keys, I'm instead mapping individual characters to the keys. And then the engrams that are produced by this, setting the length of 2 gives me the bigrams, and setting that use all lengths to true also gives me the unigrams at the same time. One transform that you'll notice is absent here is the normalized text transform. And while it can remove the diacritics and so on, I've got a particular case I need to deal with, specifically an uppercase V needing to become a lowercase u. Just one of those quirks of early modern English. So I'm handling that outside of the pipeline. I'm also skipping that LP space scaling function I mentioned before, as I just felt it was completely unnecessary. And finally, the embedding model is being exported to an ONNX file so that I can reuse it across the solution without having to retrain the embeddings model all the time. For anyone who works with Onyx files or anything like that, I want to quickly mention a site that I found called Netron, which allows you to view neural networks and machine learning models. It supports Onyx files and most of the major formats like PyTorch, and it's all open source. I'm not affiliated with it, it's just something that I found helpful when I was validating that my model was being exported to Onyx correctly, and I just wanted to mention it in case anyone finds it useful. The image there is actually a visualization of my vector embedding model. All right, I'm sure we're all familiar with Aspire, so I'm not going to go into what it is or how it works, but there is a confession I want to make. My name is Wayne, and I don't like connection strings. The property names aren't standard across databases. It can be difficult to find the documentation on what properties the database even accepts. Not to mention installing the database or configuring container port mappings and so on. So Aspire was really new when I actually started working on this, and the website part in particular. But when I needed to hook up a quadrant vector database, I found myself reaching for Aspire to handle all of that. And then when I later switched to Cosmos DB to reduce the cost, ask me about that later, it allowed me to just focus on the query code rather than setting up infrastructure or emulators. This is all there is to my Aspire app host. So we have Cosmos DB, a Razor Pages app, and taking a page out of the Aspire Entity Framework core sample, I have a separate worker that handles populating the vector database. And of course, Aspire also made all of this incredibly easy to deploy into Azure. It would be remiss of me to talk about all of this and not give a quick demonstration. So let's jump over to that and see how the vector search helps. So, as I said, this is a ASP.NET Core Razor Pages site. It only has a few pages because it's entirely driven by the data in Cosmos DB. So I'll start by searching for Stelleo. As I type, you get the normal autocomplete suggestions that you'd expect. If I type an accented character, you see we still get the same search results. And if I backspace a bit and intentionally misspell it, we still get the same results. I'm just going to hit enter rather than selecting one of the results. And here we get a search results page. So we get each of our results. You'll notice that we have an Italian word here that's styled a little bit differently. If I hover over that, we get a pop-up showing its definition. And of course, I can click on one of these and go to the actual definition. There's a link to the code on GitHub from here for anyone who wants to check it out. All right. Back to slides. All right, so what's next? With .NET 10 releasing next week and several libraries coming out of preview, there's a few new possibilities I'm looking into. So first of all, EF Core is adding support for a new vector data type, and that enables vector searches. In addition to that, hybrid search is also being enabled through EF Core on Cosmos DB for NoSQL. So that's going to allow me to simplify my query logic and also get a bit better search results on the website. So far I've been creating my own abstraction layers for generating the embeddings, but with Semantic Kernel and the Microsoft Extensions AI library, there's similar embedding and vector store abstractions already there. So I'm interested in investigating how they may simplify my code base, especially with seeding the database. It's a beast. Might also be worth exploring other vector databases. I'm sure you've all seen that several traditional relational databases, as well as several document databases, have all been adding vector support with all the talk of large language models and retrieval augmented generation. So might be worth playing around with a few of those, especially as they leave their preview stages. But like I said, I originally started with Quadrant before switching to Cosmos DB, and it's really hard to beat the price of Cosmos DB. I feel like I've had a lot of success with parsing Florio's dictionary, so I'm confident I should be able to use just basically the same template to parse other historical dictionaries with only a few minor modifications. So one I have my sights on is Randall Cochrave's A Dictionary of the French and English Tongues, which actually was published in the same year as Florio's second dictionary. I'd also really love to add Spanish or German dictionary as well. Going down this path likely means I'll need to re-architect the site, because at the moment it's very focused on the Italian. If the database is going to have a few more tables for these other languages, I'm going to need to restructure the site. Or have multiple websites, which will get a bit expensive quickly as well. Which brings me on to the last thing, reducing costs. At the moment, this is in a container app environment. If I instead switch to using Azure Static Web Apps with Azure Function backend for the actual code, it seems like a no-brainer, and it's probably going to be another excuse to use Blazor as well. I could instead host it at home instead of on Aspire, and use Aspirate or the new Aspire CLI to generate a Docker Compose or Kubernetes Helms file. But that carries a greater risk of downtime, especially with all the storms that we've been having lately. And of course, that exposes my home IP. All right, some takeaways, other than some guy I've never seen before talked about some code he wrote for a really old book. I want to say question things. It's okay to change if something else makes more sense. I said before, my original goal with this was create a translation model. That wasn't accomplishable with what I was starting with, which is the dictionary. And I think the end result that I've come up with is more accessible, and it keeps the historical context as well. Also, remember I said before that I started off with trigrams, and I thought that would be ideal. But just simplifying things a bit with the unigrams and bigrams not only gave me better search results, but it gave me that smaller vector space and allowed me to cut a huge cost out of the project. There's many ways to do things or applications for things other than the main thing that everyone is talking about. So the industry lately has seen an explosion of vector databases, whether they're dedicated or just added to a relational or document database, and that's all due to large language models and retrieval augmented generation. But vector databases are excellent, not because of large language models, but because they're designed for fuzzy searches. Also, there's many embedding models already out there for different purposes and domains, and not just for text. But if one doesn't exist for your use case, so long as you have distinct features within that data, you can probably train your own. Which brings me to ML.NET. ML.NET has a lot of untapped potential, and in the age of Gen AI, it's kind of forgotten about. It's also what this talk has secretly been about. It's a .NET standard library, so you can use it in .NET Framework. You can use it anywhere where .NET runs, including mobile and edge devices, and even in the browser with Blazor WASM. Many developers would be reaching for Python or even C to train an embedding model. But I did all of this with C#. The only other programming language I even touched in this whole project with some JavaScript for the search autocomplete. All right, that's it. Any questions, comments, or clarifications?
You mentioned
Yes.
something about the Italian use of RIE and Y and stuff.
Oh, in early modern English, we would use IE, where today we would use Y at the end of a word.
I
So,
thought there was some background reasoning or some Italian history to it, their choice of that. No.
no.
Okay.
Can you repeat the
No,
question?
oh, sorry. Bit of confusion about like the use of IE on the end of words and whether that came from Italian or not. It's mostly a early modern English thing. Maybe some French influence from the Norman invasion, which is kind of the Norse, which is the second time the Norse had invaded England.
Are you saying, okay, so French is based off a Norse?
So the Normans, the Normans that invaded England, they were basically Norsemen that had settled in France.
There's a lot more German in English than you think there is.
Yeah.
And it's French, it's old school French mixed with German and a little bit of Russian, I think, too. If you break it down.
Yeah.
So I'm a immersion kid in French, so yeah.
Yep.
Learned some of that theory along the way.
Could you explain a little bit again with regards to using the 1, 2 and 3 character where you eliminated the third character, or the 3 triplets or whatever?
Mhm.
I thought in your search it's like a return fit value that with 1 character you're getting certain best matches implied from there, 2 characters would give you further, and then 3 would give you a better elimination. You said it didn't give you better results? or-
No. So it was a question around using like the 1, 2, and 3 length engrams, and
Yeah.
the 1 and 2 seeming to give better results than the 3. So when I was using 3, it was just 3, not the combination of
Oh,
1
right.
and 2.
Okay, so it was giving 2 specific rather than the diversity.
Yeah, and one of the things when choosing like engram length is going to be proportional to whatever the longest thing in your in your training set is. So you can kind of calculate it out if you know, like, for example, in the first position, there's going to be this many this many options. In the second, this many, and you can just kind of multiply out the permutations to figure out about how long the vector space is going to be.
Okay, no, that's fine.
You mentioned about the cost.
Yep.
About
Thank you.
is that something you can?
Yes. So I actually have a few slides about that. All right. So I started off with, the question was about Quadrant and the cost. So I started with Quadrant. I was familiar with it, and don't get me wrong, it's fantastic. It has a great UI. So this is my Azure spend from July 2024. So the Quadrant container requires a minimum of 3 gig of memory for my original vector space and the number of vectors, like about 75,000 vectors across over 4,100 dimensions. So it requires a lot of memory, and that was about as low as I could get it, running on that 3 gig. So you can see here it's costing me $130 a month. And that's about 2/3 of the cost. And that's when it's working well. Something happened towards the end of August that didn't just cause Quadrant to fall over, but it would try to run 2 instances of itself. And so my cost just skyrocketed. And it was still fallen over with the 2 instances. It just couldn't do any searches at all.
Cheaper than new fencing equipment.
So around this time, Cosmos DB had just brought out its vector support into a preview state, as well as like several others like Azure SQL, Postgres, and so on. So this is because Cosmos caps its dimension size for its indexing at 4096, and my number of vectors was above that. That led me to like reevaluate the trigrams into using a combination of unigrams and bigrams, and replace it with Cosmos DB instead. I almost went a little bit crazy and starting to think about how to just write my own vector database based on something like Azure Table Storage. Like I said, crazy idea. So this here is from July of 2025. I'm basically paying the price of a pub meal each month to run the site. And Cosmos DB is like such a tiny fraction. It's been like $5 within the past 12 months. The most expensive part now is just the container for the web app, and I can probably eliminate that cost as well.
So when you were moving between these databases, how easy was it, like from the code perspective? When you want to switch from the 3 to 2, do you have local support, or do you have to push it to cloud and then?
Okay, so the question was, how easy was it to switch from like Quadrant to Cosmos? Could I do things locally, or did I need to provision in the cloud? It was quite easy. So I'm using Aspire, and Aspire will, well, if it's containerizable, it'll pull down a container from Docker. If it has, well, actually even the emulators like Azurite is a container that it pulls down. And for Cosmos DB, it also has an emulator as a container that it will pull down. So I was able to just do that and like just focused on actually changing the query code. I still have, if I jump over to Visual Studio, I actually still have the library for my Quadrant queries as well as the Cosmos DB ones, so you can have a look. But of course, like had abstractions, so already had a contract to write them to. So it was just figuring out the specific query itself. And like Cosmos DB for NoSQL allows you to use essentially SQL queries to write it, or there's also like link-like.
You must be a .NET developer for a while. Visual Studio, I haven't seen that. I haven't moved off it either. Might know I don't code much. So you mentioned the relation like Postgres being open source and whatever is usually fairly cheap, but wouldn't expect it to be about $5 or whatever. But the SQL vector and the Postgres vectors, didn't come into your play because they were exceptionally expensive, or was there some other process?
Yeah, so you're asking like why I didn't use like Postgres or SQL, and why I chose Cosmos DB itself?
Yeah.
Yep. So Cosmos has a Postgres option as well. I trying to remember. I don't think the vector support was in the Postgres Cosmos DB option at that time, which is why I went for the NoSQL one. And then also like the NoSQL one, I can just run it serverless, and they even have a free tier for a certain amount of DTUs.
Nice to hear someone saying Cosmos is cheap.
First time I've ever heard that in my life. It's looking up, like there is vector-based SQLite, and I know people have done some really huge
Okay.
SQLite where they host the database on a GitHub page, it's just a static file, and then run it through a WASM thing on the client. So I've seen that, but not for ML stuff. So.
Okay. I would,
Still dimensions though.
yeah. So with the vector support in SQLite, I remember there was a Stephen Tube blog post where he was writing about retrieval augmented generation, and maybe it didn't have the vector support at that time,
Well, it's not
but
something
he,
that's a branch of it, but yeah.
yeah, but yeah, he said that I don't think it was actually indexed. Like you would have to go through and select every single row to do the cosine similarity search.
So what's your next thing you're going to do with ML.NET?
Not sure. So, yeah, the next thing I'm doing with this project is, yeah, Randall Cotgrave's dictionary and re-architecting this a little bit. Probably keep the same pipeline, ML.NET pipeline, because it seems to work, but I could certainly customize it for each language that I add if it needs.
If all of the words are going into a vector, are you going to be able to search across all of the languages? Like all the...
Yeah, I've yet to. So, as far as searching across all the languages, I guess it's going to depend on how I structure that part in the data. Like if I use a separate container for each language, maybe not. But if I try to put them all in and find a good way to partition it, it might work better. But I'll burn that bridge when I come to it.
You couldn't get away with another dimension and have the languages along that dimension and have a distancing dimension.
Yeah, I could possibly put the language in the dimension, maybe.
It'd be interesting to search for a word and actually see them come up from, as we're all talking around the different roots of the different parts of the older languages, is to type in a word and go, oh, there it is in 3 different languages historically. And
Let alone plural words, like the incestuous English-French thing.
yeah, 100%. It's super cool.
Mm-hmm.
Beef and mutton, all the high class are still all those words are French and English, and they're just straight stolen.
And then sell it to English teachers.
Sorry?
And then you could sell it to English teachers.
Sell it to English teachers, yeah.
That's awesome.
All right, thank you.
We've got plenty of time for questions if there's any other questions, John.
Do you have the plan to expand this onto ML.NET ONNX integration? Because the ONNX has a large component for vector search.
Yeah, so am I planning to expand it to ONNX? Yeah, Onyx. So I'm already saving it out to a Onyx file, and yeah, and then re-importing that. So basically, when I build to deploy, I'll first run a training program that trains the embedding model. It'll output an ONNX file, an Onyx file, and then the Vector DB Manager project and the web app project, they both have copy references to that file path, so that they will deploy with the Onyx file.
All right. Well, let's put our hands together and thank you, Andy.
Thank you.
Thank you, Rick. We have one of our other sponsors other than Microsoft is JetBrains, and we have a couple of free JetBrains. Pick a thing that you like for a year for free, which we generally just give them out to the people with the best questions. So if you wanted to pick your 2 favourite questions and hand them out, if they don't want it, you can just pick again. Otherwise, you can call for hands if you like.
Anyone already have a JetBrains license? No.
Anyone who would who asked a question and would like a JetBrains free subscription.
Yeah.
Adam, you're up because you were the first one to.
Awesome.
And
Gentlemen, try it out. You know.
Has anyone tried Rider? Yeah. So I love VS Code for my front end stuff, but as a C# guy, So Rider is way better than
VS Code.
Yeah, than
Yeah.
VS Code for C#.
Go on the end as
Yep.
well,
He's
like a
giving a nod.
license.
Okay.
Yeah.
Well,
Thank you.
You've asked some good questions as well, sir. So thank you. Enjoy. And if you've already got Rider, you can try something else. Pick whatever
So
you
Todd,
like.
I thought with your new company you'd be able to dictate all these terms of employment and subscriptions to help you productivity-wise.
No, I don't. Do we know anyone at JetBrains?
Oh, I don't know. Yeah, good question. I don't want to keep everyone all night. Before we finish up, I just thought I'd mention that this is probably the last meetup for this year. So we don't have anyone speaking in December, and December's kind of Christmas silly season. So we generally skip Christmas anyway. There is a Brisbane Tech Drinks meetup thing that you can go to. There's a cost involved, so but it's a great opportunity to to meet up like across all of the tech meetups with different people from different languages and different ecosystems and all that kind of stuff. Also, DDD Brisbane, I'm not sure if it's sold out yet. DDD Brisbane is $49.
Tickets are still available as of 2 days ago.
Tickets are still available.
It's kind of good.
It's literally the best conference in Brisbane every year, in my opinion. Certainly price versus performance. It's $49 and they feed you and you get a whole day tech conference at QUT, Gardens Point. Z Block, if you know QUT well, $49, a whole day. You can't go wrong. Get your ticket before it sells out every year.
The schedule's going to be announced this week.
Yeah, I think it's a couple of days away.
Which is when all the tickets disappear.
Well, if you're smart, you just get in early, right? Early bird, just get in. Does anyone else have any other announcements about anything else that's happening between now and Christmas they wanted to call out?
.NET Conf next week.
.NET Conf next
Yep.
week. The
Yep.
man. I mean, you've seen it before, but see it even more polished next week. Why not? So we'll come back in the first week of February. So we won't have a meetup in January because it'll be like the 3rd or 4th of January and it's just too close to Christmas and New Year's, but we'll come back in Feb. We currently don't have any speakers, so if you're interested in speaking on any topic, you can see Wayne had a really interesting topic, but it was .NET related. You're welcome. Please message us on the meetup or message me on Twitter or wherever, or on LinkedIn or wherever you can get to us. My name's Todd Thompson, Cam Smith here. If you know any of us on LinkedIn, just message us there. And we'd love to have proposals for talks. Doesn't have to be AI related. It feels like every talk is AI related at the moment, which is totally fine. But also they can talk about, optimizing EF queries if you want. If JK's not here, but he loves talking about optimizing EF. So you can just talk about anything .NET related. So please do propose something. It doesn't have to be, an hour, an hour and a half. It can be 5 minutes. It can be 20 minutes. It can be half an hour. It can be an hour. Whatever suits the topic and your confidence with public speaking. And we can support you to come along and speak in any way, shape or form that you like. So if you need any support, please let us know. We can review slides or give feedback or do dry runs or on Teams or Zoom or something like that. So, and tell your friends, and that's it. And thanks again to Microsoft for the pizza in the venue. Cheers.
JK's into ML.NET. He's been with it from the beginning. Get him to do something with Blazor or something. He'll give him like that.
Well, yeah, I think JK actually threatened to come and talk about AI. I'm just waiting to hear back from him, so I'll nudge him again and see if I can get him for February.
Hopefully this time, he brings his power cord and his adapter.
So his GPU doesn't, actually works or whatever the problem. I can't remember what the problem was, but he couldn't make his computer work properly without a power cord. So we had a very short talk that night. Yeah, thanks everyone. Stay around, ask Wayne questions, and we'll see you in Feb.